Hi folks, welcome to this little video on weather and synoptic charts. Going to put another couple of videos together, but this one will start everything off. And if there's any questions, feel free to pop me an email and ask. So we're going to look at weather and synoptic charts. The aim of all of this is to be able to look at a synoptic chart and have a reasonably good idea about what's happening, what's going to happen, and then we can relate that to our location. What's the sea state going to be like? What's the tide doing? How will the impact of any weather affect us when we go boating, whether it be sailing or whether it be motorboating, power boating, stand-up paddleboarding, whatever it may be. So we're going to have a look at the much bigger scale of wind direction and what that does to the UK, why we feel cold in certain wind directions, why does a southwesterly bring rain and it's warm, why is a southerly wind dry and warm. We'll have a look at synoptic charts, we will have a look at fronts, and then we will have a look at kind of a cut through of a depression, kind of a low pressure, and see how it all fits together. So, to kick things off, we've got Northern Europe and we've got the UK. So let's simplify it for a minute. Let's look at 4 different wind directions: north, east, south, and west. From the north, it's what we call polar winds. So that's going to be straight from the Arctic. From the east, it's continental. From the south, it's tropical. And from the west, it's maritime. It would be really straightforward if wind blew from one of those 4 directions and that was it, but it's not, sadly. So if we kind of take polar, it's cold, it's dry. Although there is vast amounts of water up at the poles, it's all frozen, which means there's not going to be much rain. However, that in turn creates its own problem, because what we have with polar wind is cold air, which when it meets the warm, moist air that comes up from the tropics, we get snow. Think beast from the east scenario. A northerly wind, even in the midst of summer, is rarely warm because the Arctic is still there and it's still cold and it's still frozen. So all the air that drives down from the north is going to be cold. The continental one, easterly, one that changes quite significantly by the time of year. Again, very little moisture because it's from the continent, there's land, there's very small amounts of water for it to move over. It's going to be relatively warm in the summer. I think Dubai, kind of Middle East, and all the heat that comes from there. But equally, it's going to be quite cold in the winter. Tropics, that is going to be warm 12 months of the year. The reason it's tropical is, as it's just alluded to, it comes up from the tropics, which are always warm no matter what time of the year we are in. And then the last one is maritime. That comes from anything to do with water. So west of this little icon, we've got a few thousand miles of water, North Atlantic, for it to be picked up and pretty much dumped in the UK. And that's one of the reasons why our UK weather is so changeable, because the wind direction shifts depending on what's going on. When we start to combine these two, polar maritime, we get cold and wet weather. Polar continental is just cold, but relatively dry. Tropical continental doesn't tend to do anything other than put a lot of heat into what we've got. But it's really kind of tropical maritime that it starts to get a little bit kind of more interesting. Reason being is a southwesterly wind is the most common wind direction. It's the prevailing wind in the UK. And that's going to combine all the moisture from westerly with the heat from a southerly wind. So it's warm, moist air getting pulled up from the tropics and the equator, picking up all that moisture and then dumping it on the UK. Certain parts of the year, you can get at least a 10 or 12 degree temperature change one day from the next. If it blows northeasterly, it's going to be really cold. And if it switches around to the southwest, the temperature will increase by about 10 or 12 degrees. But sadly for us, that's probably going to mean a warmer day, which is great, but lots of rain as well. And we'll go on to why we get lots of rain from the southwest a little bit later on. So a little bit of a recap on what we've just done. So warm and moist oceans, tropics, that's what we call tropical maritime. Warm and dry from the desert regions, the Sahara, tropical continental. I'm just staying with this one for a second. This is the reason that we get one of my favorite types of weather. And on the theory courses run in the classroom, I quite often get people to list as many types of rain as they can think of. And very few people come up with dry rain. And the few that do know exactly what I'm talking about, and everyone else thinks I'm a bit nuts. But we do get dry rain. It's obviously not wet because there's no moisture in the air, but the dry rain is literally what's in this photo here. It's sand or very similar kind of types, and that will just get picked up with the wind and moved all across southern Europe. Used to be very common in Greece. Most of the south coast of the UK will get some kind of dry rain at some point, and it will coat the cars, kind of bins, windows, like a very fine kind of dust, and it does turn everything kind of sandy colour. Quite rare, but it does happen. Cold and moist from the Arctic, the Atlantic Ocean, polar maritime could just bring kind of sleety conditions, but equally could bring quite heavy snow. And then the last one, polar continental. If we combine the first one, tropical maritime, with the fourth one, polar continental, we've got what we encountered as beast from the east a couple of years ago. We had polar continental northeasterlies meeting tropical maritime southwesterlies, and the boundary between that weather was right down the middle of the UK, which is why we had all that snow. So this is what it all comes down to. This is a kind of simplified version with all the add-ons around the outside cut off. This is a synoptic chart from a good few years ago, so December 2012. A couple of things to note. We've got a low pressure, and we can always find the low pressure on a synoptic chart because it's accompanied by red lines, which are warm fronts, blue lines, which are cold fronts, these purple wavy lines coming off it, occluded fronts, it's where the two combine. And normally, a large amount of black lines with a load of numbers on them are really kind of tightly packed together. These black lines are what we call isobars. And we'll come on to what all this means in detail a little bit later on. Nice big high pressure down here. This is the European high pressure, and it's always there. It just moves a little bit further south in the summer. And we've got a little high pressure poking up here, the bottom left hand of the screen. The Azores high pressure, and that stays there as well. It just moves a little bit further north or south, depending on the time of the year. So the winter it gets pushed down, and the summer it starts creeping up towards us. So low pressure, high pressure, isobars. The red warm front is the boundary, it's the meeting point between the colder air over here on the leading edge and the warm air in behind it here. And we call that the warm sector because it's a little sector, like a little segment of warm air. We've got our cold front, and this is the boundary, the meeting point between all the warm air and the warm sector here, and the cooler air moving in behind. The way to think of fronts are essentially battlegrounds between two air masses. So we're either going to have warm air and cold air, and the two of them are constantly going to battle, join, move. When we get a warm front, it means the warm air's won the battle, and we get a cold front, the cold air's won the battle. This last section over here that we can pick up from this chart is an occluded front, and that happens in two particular areas. One on a low pressure, when the warm front and the cold front essentially zip up and join together, and then the characteristics will differ. I tend to refer in some of the theory courses, if you imagine a line and you've got a cold front at one end and you've got a warm front at the other, that occluded front will take on the characteristics of those fronts depending which end of that line it's on. So if it's more of a kind of a warm front, occluded front, you're going to have more heavy persistent rain. And if it's more of a cold front type occluded front, then it's going to be more kind of isolated squally showers. And if it's in the middle, well, it could do either. And the last thing that we can tackle here and identify are these little black lines, and there's a couple of them dotted around. There's 3 in the Atlantic, and then there's one over towards the kind of eastern end of the Med and the Aegean. So these little black lines are what we call troughs. Very simply, think of them as a very localized, deep area of low pressure. They can bring kind of characteristics within a kind of a low pressure, wind and rain, a bit more of a kind of a serious squall, and then it will clear off and it will move away. Really hard to forecast, really hard to predict where they're going to be, but they do get scattered around a synoptic chart from time to time. So looking at a synoptic chart, we should be able to identify a couple of things. The one big thing that stands out for me, besides where the fronts are, is where it's going to be windy and where it's not. And anywhere around this low pressure system, it's going to be windy because the isobars are tightly packed together. And on this high pressure system down here, the isobars are not tightly packed together, so we're not going to expect very much wind. The second or third thing I can identify, and that, just bear with me while I bring up a kind of a marker, and we'll go yellow. Okay, that's the wind direction that we're roughly going to get. I can identify that because of where the fronts are pointing. We've got this cold front pointing that way. We've got this warm front pointing north. At the same time as these kind of fronts are moving, the whole low pressure system is moving anti-clockwise. And a little bit of kind of background information here. All the low pressure systems kind of form in the kind of the southern part of the Atlantic and trek across the UK towards us. So they move from the southwest to the northeast while they're rotating. We can tell a number of things from this, and I'm just going to come back with my little yellow pointer, and you can see if I draw a couple of lines on these synoptic chart lines, the isobar lines, we can start to get an idea of what the weather's being in the wind, and the wind's the crucial bit. Any isobar line, you can draw an arrow on it. On a low pressure, the wind gets pulled in by about 30 to 40 degrees on average from that isobar line. So that's why we've got lines, the first line that I drew, and then we've got the second arrow coming off. Reason for this is the low pressure creates a vortex that pulls everything into the middle. So that will give you a bit more of an accurate wind direction at the location in which you're on the water. And we'll come back onto this in a little bit more detail. Okay, so a little bit of a recap of what we've got. So isobars, joining points of sea level pressure. About 1013 is the UK average pressure. Anything below that, and we're generally going to be looking at low pressure territory, and anything above that, we're going to be looking at high pressure territory. As a side note, and we'll go into this in a bit more detail when we start talking about tides on a different video, as the pressure drops, so a low pressure gets moved into the UK, that pulls the water level up. As a high pressure moves in, that pulls the water level lower. And that, in some cases, significantly affects flood defences, going under bridges. It can also affect tidal water if you are operating in an area where there's lots of fresh water in addition to tides. And the best examples, two examples close to where we're based on the Clyde. One is the top of the Clyde at Glasgow. We were recently up there doing some filming, and for the first 7 hours we were filming, we just started at the turn of low water. So we're at about 6.5 hours up to high water, and the water level was rising, but the very surface current was going back down river as if it was simulating an outgoing tide. And this was because there was so much fresh water further upriver from all the rainwater we had. The other location is Loch Lomond, which in the very bottom section of it is a tidal location. It does go up and down quite dramatically. It's affected much more though by rainwater and low pressures and high pressures. And the further you go up to the north of Loch Lomond, the more that is very evident. And the water can move by about 2 or 3 meters depending on how much rain has happened or is happening. So we can use an isobar to identify wind speeds and wind directions. We can see instantly where the high pressures are, and that's what we call anticyclones. And we've got low pressures and depression, or what we call depressions. And we can also pick out troughs as well in black lines. Ridges, kind of a ridge of high pressure moving in, that's what we call that. But keeping it simple for now, we've got anticyclones, high pressures, and depressions, low pressures. So instantly, let's start talking about a depression, aptly named. Depressions and low pressures. It's windy, it's wet, it's changeable. 3 words to describe a low pressure. Anti-clockwise around the low pressure in the northern hemisphere. Round about the low pressure, the clouds are going to start to play a factor. And it's really quite easy to see a depression coming in because the clouds will change. And I'm going to record a video on clouds and upload it as well to our YouTube channel, so we can chat in a bit more detail about what clouds do. But the reason we pay quite a lot of attention to what depressions do is because they bring wet and windy weather and an increase in sea state and an increase in water level as well. So as a recap on depressions, we've got unsettled weather. It's very changeable. This is a picture one, but it kind of depicts very nicely what happens. So we've got an occluded front here where the two have started to zip together. Anti-clockwise rotation. We've got a warm front kind of leading down the middle of the Irish Sea. Warm sector in the middle. And then we've got our cold front, which is sat across Ireland at the moment. As always, a west to east direction, tightly packed isobars, strong wind, kind of vortex into the center of the low pressure. And as it says in the second bullet point there, it does bring a vast amount of rain. And that rain across the passage of a low pressure changes from very light drizzle to gradually kind of heavier, more persistent rain. The middle section here, the majority of the rain has passed under the warm front. So in the warm sector, we tend to get drizzle. And then as the cold front approaches, the drizzle tends to become more kind of squally isolated showers. And then the squally isolated showers will get less frequent, less heavy as their system passes away, and we end up over here in relation to the low pressure. So high pressure. Let's bring in some nice weather. So it's clockwise, northern hemisphere again, remember? Anticyclones, even though they spin clockwise, generally get more settled weather. And even in the middle of winter, a nice big high pressure, although it will be reasonably cold, it will be sunny, and you tend to get that weather for about a week or so until that high pressure kind of fizzles out and the next low pressure moves its way in. And we're never too far from a low pressure in the UK. Nice and sunny, warm weather in the UK. In the middle of summer, frost, fog, cold, dry, icy in the middle of winter. And you can see from this photo that a high pressure looks very different. There's a lot less stuff moving on here. We've got isobars that are kind of relatively spaced. It's not very windy. There's no fronts hanging all the way down through the UK. There's no cold front over here. So there's generally a lot less happening. So we can summarize at these points that are here very nicely. Settled, and it probably will be for about a week. On the whole, reasonably clear skies, but let's not rule out fog and everything that occurs with fog. And I'll talk about that in a later video. It's a wind angled away from the center. So it's trying to disperse the wind, which is why we get lighter winds. Again, kind of generally a west to east, and it'll move in from the Atlantic and sit in the UK for a while, and widely spaced isobars. So this is one little kind of synoptic, a kind of a cut through of a synoptic chart that I come back to time and time again on shore-based courses. And it's really quite good because it lets us see what is happening and try to kind of imagine it. So right up here, take a nice summer's day, blue sky, and we'll get some kind of indication that the weather's going to change, whether that be a forecast or simply looking up at the sky and going, hang on, there's a few clouds up here. Let me have a look at my app on my phone and see what's happening. And it could be the next day that the forecast is going to be pretty wet and pretty windy. And it's going to take the rest of that day and night for that low pressure to move in. So what we can see from starters is the warm air is rising. That's what these two lines are indicating here. We've got cirrus clouds, high, thin, kind of wispy strands. Start to move into kind of more layered clouds. Anything that's got stratus in the name is a layer. So cirrus, kind of high frozen layer of cloud. Altostratus, just starting to lose the frozenness of the cloud, but still starting to layer. And at this particular point, we start to lose the sun. We throw in a couple of altocumulus clouds, so they're starting to kind of heap a little bit. And anything to do with heap clouds is going to mean rain. Nimbostratus follows, and this is the crucial bit because this is just after the warm front hits, or just on the warm front. And nimbostratus clouds are really heavy, persistent rain. A wall of rain going to move across as that front passes overhead. The good news is the rain is not going to last forever. In the middle here, this is what we call our warm sector. We've got kind of stratus and kind of stratusy clouds. And that could turn into fog depending on the visibility. The crucial bit is we've lost the nimbo from the name, so we've lost the rain element of it. And they're literally just low-lying clouds, occasional bit of drizzle, bit of mist, not a great deal else happening in terms of cloud and rain anyway. And then it all changes. So then we get the cumulonimbus cloud. And this is the towering thundercloud that brings all kinds of funky weather. The cloud, you're going to most likely to get squally showers, possibly thunder and lightning depending on the time of the year. We could get thunder snow depending on the time of the year as well, and also hail, or any one of the above together. Why do we get this? Because we've got warm air over here and cold air suddenly moving in behind it and forcing it up quite rapidly. And that forces it into a kind of a tumble dryer effect. It's rising, cooling, dropping, and then meeting the next kind of influx of warm air. And it turns into reasonably violent battleground, which is why we get the thunder snow and the thunderstorm. In addition to those clouds and everything else that goes on within the cloud, what we see under here, under the cloud, is generally heavy squally showers. It's not heavy persistent rain like we get over on the warm front here. Squally showers that will stop, but it will build up again and the next squall will come through. And then the good news is that's the two fronts past. And then we are going to start to look at cumulus clouds, kind of the white fluffy clouds. On one hand, that's good because it shuts the door to one low pressure system. On the other hand, it's bad because the pressure's risen again, which opens the door to the next pressure system to work its way in. But there is a period here where the weather is generally quite nice. Last slide for this particular PowerPoint. This is an overview of a low pressure system showing the clouds, and we can quite quickly, if I've got a drawing tool and yellow, just bringing it up. What we've got here, okay, is one system going down there, and it probably extends all the way around here, but it's this little bit that we are interested in. True synoptic chart style, let's redo that, and I'm going to color it red because that's our warm front. Over here, we've got our cold front, and quite possibly in this section here, we've got our occluded front. The reason I can tell that is we've got a huge big band of cloud that comes in here. So this is the heavy nimbus stratus rain all along the warm front. Cloud and not a great deal happening here, and then the squally conditions start. We can see exactly where the center of the low pressure is, and that's where my X is there. I can tell that because there's gaps in the cloud. All else around it, that's all cloud, and cloud generally means rain. Warm front, heavy rain, cold front, squally showers, occluded front where the two have joined, kind of moving off here. A combination of either, but some kind of drizzle and kind of lightish rain. Okay. Thank you very much for watching, folks. On our YouTube channel, we've got another couple of videos on the shipping forecast and on clouds as well. And if you've got any questions, please feel free to send me a message or an email.